Hi guys, as we go through this next unit, we are going to need to be able to factor. So this is something that should be reviewed, but I just wanted you to take a day and review different techniques for factoring. So remember when we factor or write as a product of linear factors, we're trying to get all these m's separated. So right here we have m to the third plus 3m squared plus 2m. We want to the first step in factoring is always to look at each term and see if there's a common factor or actually a greatest common factor. So we want to pull out the greatest common factor, which in the case of number 1 would just be an m, because each term has an m in common. So I'm going to pull one m out front of the parentheses, which should leave m squared plus 3m plus 2 inside the parentheses. You can always double check that you got it correct by multiplying that back through the parentheses. You should get the same thing as you got in number 1. So we separated one of the m's out. We still have m squared here, so we want this to be in the form where we have m here and here. And the way we do that is, remember, called x factoring. So up in the top, we would want a times c, which in this case, since a is 1 and c is 2, that would just be 1 times 2, which is 2. And then on the bottom, we want b, which is 3. We want two numbers that multiply to 2 and sum to 3, or add to 3. So the only two numbers that will multiply to 2 and sum to 3 are 2 and 1, which makes our factored form m plus 2 and m plus 1. So once all of our m's are all separated out, we're done. Remember, we would always want to take our little factors that we just found and divide them by a, but since a in this case is 1, it's not going to change anything. On number 2, it looks like they have a common factor of x squared, so we can pull that x squared out front, which just leaves x plus 2. So that really is all we needed to do here. This one is still squared, so technically we could write it as x times x plus 2 to get all of our x's separated. I would take either answer on that one. So 3 is going to be very similar to 2. I'm just going to go through and do some different examples. So on number 4, it looks like we have a common factor of 5. So pull that 5 out front first. Would be p squared minus 4p minus, let's see, it goes in 32 times. All right, so now we're looking just at what's in the parentheses. We're going to x factor that. So a is 1 and c is negative 32. So 1 times negative 32 is negative 32. B is negative 4. So looking for two things that multiply to negative 32 and add to negative 4. I think that would be 8 and 4. We would want the 8 negative so that when we add negative 8 plus 4, we get negative 4. So this would give me p minus 8 times p plus 4. Then I would want to divide each of my numbers by a, but again, a is 1, so it's not going to change anything. So there's my factored form. Let's look at one that does not have a as being 1. So it looks like we could do, do we even have any on here? All right, let's look at number 17. So we're going to x factor. There's no common factor between 2, 13, and 45. This one doesn't have an n, so there's no common factor here. We want a, which is 2, times c, which is negative 45, which would give me negative 90, and b is negative 13. So I'm looking for two numbers that multiply to negative 90 and add to 13. So let's see, let's see, we've got 1 and 90, which obviously won't work. We've got 2 and 45. We've got 3 and 30. 4, 15. No, that won't work. 4 won't work. 5 would go in 5 and 18. There we go. So 5 and 18, because 18 minus 5 is 13. So we'll do negative 18 and positive 5. So that would give me n minus 18 and n plus 5. And then remember, we just need to divide each of these by a, which a was 2. If that 2 goes evenly in, we're going to go ahead and divide it. So 18 divided by 2 is 9. Since 2 will not go evenly into 5, I'm going to take that 2 and I'm going to move it in front of n. So 2n plus 5. So there's our factored form. All right, now let's go back up here a little bit. Well, let's just do a number 16. So notice I have 4 terms here. There's not a common factor between all 4 terms. This is what we want. This is where we want to use a different method of factoring called factoring by grouping. So I'm going to group the first 2 together and I'm going to group the last 2 together. I'm looking for common factors between just these first 2. So they both have an r squared. They both have a factor of 5. So I'm going to pull out 5r squared just from this first group, which would leave me with 2r plus 7. 2r and 7 in my second group don't have any common factors, so the only thing I can pull out is a 1, and I'm actually going to write that 1 there, even though generally if it's just a 1 we wouldn't write it there, because it's going to help me in my next step. 2r plus 7 and 2r plus 7, those are the same. So just like in this first group right here, like 5 and r squared were common factors between these 2 terms, this term here and this term here both have a common factor of 2r plus 7. So I'm going to pull out the 2r plus 7 in front, just like I had pulled out 5r squared in front of this term. And if I pull that out, it's going to be just leave the 5r squared. And if I pull out 2r plus 7 from this term, it's just going to leave the 1. So 2r plus 7 times 5r squared plus 1. That one is an r squared still, but, well, I guess we could factor it one step further. But in order to do that, we're probably just going to have to set it equal to 0 and find our zeros, even though that's not what it's asking us to do, and then put them back as factors. So here I'm going to subtract 1 from both sides, which would be 4r squared, 5r squared equals a negative 1. Divide by 5. So r squared equals negative 1/5. I would take the square root to get rid of the squared on r. So r would be equal to plus or minus I square roots of 1/5. Remember, if you have a negative under a square root, it's going to give you an I. And if I'm taking the square root of 1/5, it's not going to simplify, so I would just leave it like that. The plus and minus is because anytime you're taking the square root of a squared, you could get the positive or negative of that solution. That's because, as a side note, think about it for a second. If I have 4 equals r squared, so again, totally unrelated to this problem, but what could r equal here? It could equal 2 because 2 times 2 is 4, but it could also equal negative 2 because negative 2 times negative 2 is also equal to 4. So anytime you're taking the square root of a variable that's squared, you're always going to have 2 options for your answer, the positive and the negative of your answer. So that's why I have a plus or minus in front here. Now these are the zeros or the roots for this. Remember, if I have the zeros or the roots, I can write them as zeros by putting them like in this form where I would have r, for the positive one, I would have r minus I square roots of 1/5. And for the negative one, I would have r plus I square roots of 1/5. For this assignment, actually, let's just stick with this. We'll go to this form. If it doesn't look like you can simplify that one anymore, then just leave it like that. But we will actually talk more about this later on. Let's try one more example of by grouping. Let's do number 13. So I'm going to group the first 2 together, oops, and I'm going to group the last 2 together. Notice here though that this one has a negative between the middle 2 terms. If I just throw parentheses around those 2 terms like that, this negative is then going to need to be distributed to both terms, because remember, if you subtract something that has more than one term, that negative has to distribute through, which would actually change our problem to 5r cubed minus 2r squared minus 25r minus 10, which is a different problem than we started out with. So that is going to cause a problem. So in order to fix that problem and to make sure that we're not changing our problem and giving us a negative 10 where we wanted a positive 10, we're going to make sure, instead of just putting the parenthesis there, we're going to put the parenthesis there and pull that negative inside on negative 25 and then change that one to a plus. What that does is keeps our problem the same but still allows us to group those last two together. So 5r cubed and negative 2r squared, their common factor would be r squared. So I'm going to pull out r squared, which would leave me 5r minus 2. Negative 25r and 10 have a factor of negative 5 in common. So I'm going to pull out, since that's a negative 25, I'm going to pull out a negative 5, which would leave me with 5r minus 2. Remember, because negative 5 times negative 2 gives us that positive 10. So now they have this common factor of 5r minus 2. So I'm going to pull that 5r minus 2 in front of the expression, and that would just leave r squared minus 5. Again, later on we'll talk about how to break up this r squared, but for now let's just leave it like that because r squared minus 5 is not a perfect square, so it's not a difference of squares, so let's just leave it in that form. All right. This one right here, I could use x factoring. My b term, the middle term with just an r, is missing, so I know that the two numbers are going to add to 0, and then they need to multiply to negative 100 because a, which is 4, and c, which is negative 25, multiply to negative 100. So the only two numbers that multiply to negative 100 and add 0 are negative 10 and 10. So this would be r minus 10 times r plus 10. Divide each of those by a, which is 4. We'll reduce this fraction, so this is r minus 5 halves and r plus 5 halves, just reducing 10 over 4 to 5 over 2, and then that 2 will move in front of r. So 2r minus 5 times 2r plus 5 will be the factored form. Okay, the final type of example you're going to have today is these ones where we have a 4th degree and then a squared. As long as it has this pattern where it's 4th and then squared, we can still factor this using x factoring. The only difference being that when I factor this first part, I'm going to want to write x squared instead of just x, because x squared times x squared does give me the x to the 4th. A is 1 and C is negative 6, so if I multiply those I'll get negative 6. B is 5. So in order to get a negative 6 I need a positive number and a negative number, so I'll do positive 6 and negative 1. If I multiply those I get negative 6. If I add them I get 5. So this would be x squared plus 6 and x squared minus 1. Now like I said, if I have this x squared in here, don't worry about simplifying it one more. We'll talk more about that later. I did show you how to do it once, but I know it's difficult. So let's leave it like this. The only difference being that on this one right here, since I have x squared minus 1, since 1 is a perfect square and there's a minus here, if both of those things are true, your last number is a perfect square and your middle number is a negative, then you can go ahead and factor this one step further. 1 is a perfect square because 1 times 1 equals 1, and then this does have to be a negative to do this, but this would just factor to x plus 1 times x minus 1. All right, that's because think about just this little section right here, x squared minus 1. A is 1 and C is negative 1. So 1 times negative 1 is 1, just x factoring this. B is 0, so the two numbers that multiply to negative 1 but add to 0 are 1 and negative 1. So that's why it factored 1 down. The x squared plus 6, since that's a positive and 6 is not a perfect square, I'll just leave it like that. So let's just try this last one, number 7. 6, 84, and 288 do have a common factor, I believe, of 6. Let me check my calculator really quickly. 84 divided by 6 is 14. So I'll pull out a 6 here. This will be a to the 4th minus 14a squared. And then 288 divided by 6 is 48. So plus 48. So ignore that 6 for a minute. We're going to x factor this what's in the parentheses, but remember we would have to put a squared here instead of a. A is 1 and c is 48, so this number would be 48. We need to multiply to 48 and add to negative 14. So let's see, we would have 1 times 48, which won't work. We could have 2 and 24, which won't work. We could have 3 and 16, which won't work. We could have 4 times 12. We could have, 5 won't go in. Let's see, 6. 48 divided by 6 is 8. There we go, 6 and 8. So 6 and 8, if they're both negative, negative 6 times negative 8 is 48. Negative 6 plus negative 8 is negative 14. So if we put negative 6 and negative 8 here, we're good. If these were perfect squares, we would go one step further because they do have a minus there. But because these are 8 is not a perfect square and 6 is not a perfect square, just leave your answer like that. I would want to divide each of these by a, but again, a was 1, so it's not going to change anything. All right, guys, so good luck. Just practice that factoring, and if you have any questions, please let me know.